Hello guys, Waec 2020 is here again. Thanks for coming back again. If you are my subscriber and if you are yet to subscribe, this is high time you click on the subscribe button and also on the bell beside it. That will notify you when we drop a new video. We want to look at practical mechanics and we are having these materials ready for the experiment. Okay, we firstly identify those materials we're going to be needing and the apparatus required for the experiment. Then we go through the procedures and the diagrams for the experiment on the whiteboard. Then the next thing is to perform the experiment and see how it goes, plot our graphs and so on. So let us identify the materials. We will need a meter rule. This is a meter rule calibrated from 0 to 100 centimeter. So that is 1 meter. So that makes it a meter rule. We will need a knife edge. This is a knife edge. So you should know what the question is likely to talk about. So we're going to work on moment and equilibrium of forces. So then we have masses. We have 20 gram mass, of which we have the multiples in 8. So we have the 20 gram mass, as you can see. We have the 20 gram masses in 8 places. And at the same time, we have the weight angle, what we use to hang the weight on the meter rule. However, we have the thread. We have a piece of thread or string, and there is a reason for this as well. And at the same time, we have 100 gram mass. So this is 100. In case we might not want to use the multiple of 20 in 5 places, so we have the 100 gram mass. Okay, we also have weighing balance, but sorry, I'm not going to show the weighing balance now. So we're going to start the experiment and see how the experiment goes. So don't forget the normal routine in all labs. All procedures should be followed and ensure that your table is well recorded so that you would not have errors. As I've said earlier, don't forget the table when you take a reading should be in 2 decimal place. When you make an evaluation, it should be in 3 decimal place. However, your values given to you in masses, of which we are going to make use of in the video, should be in 1 decimal place. So let us go through the procedures and see how to start the experiment. Okay, let's start by going through the diagram first and then go through the procedures. Then we see how to start the experiment. So we have the meter rule in this diagram here. So and then according to the procedure, we are provided with the knife edge, which I've displayed the other time. Then we have the weight angle, which are represented with this, which means a mass will also be angled on that. So then we also have the thread or string, which is actually here. So that is the string, and we're going to set up the apparatus this way according to the procedure. You see, let's read. You are provided with a uniform meter rule, a knife edge, masses, and other necessary materials. So the first step is suspend the meter horizontally on the knife edge. Read and record the point of balance G of the meter rule. Now, using the thread provided, suspend the weight angle with mass M equals 20 on one side of the meter rule. Adjust until the meter rule balance horizontally again. So once we hang the mass on the weight angle, then we adjust the meter rule until it's balanced again. So then the next thing is read and record the distance L between the mass and the knife edge. Repeat the procedure for 4 other values of M equals 40, 60, 80, and 100 gram. As we can see here, repeat the procedure. Okay, I think I mentioned this the other time. Read and record the distance L between the mass and the knife edge. Then after that, we have repeat the procedure for 4 other values of M equals 40, 60, 80, and 100. So in each case, record the value of L, then evaluate L inverse in each case, tabulate your readings. After tabulating your reading, you are meant to plot the graph of M on the vertical axis against L inverse on the horizontal axis. Then determine the slope S of the graph. Then we evaluate X equals 50 all over S. And at the end, we take precautions that we take to ensure accurate results. So now let's see how the experiment will go. Now we have balanced the knife edge horizontally. You can see it is actually balanced, so without movement. So it has balanced to check the center of gravity. So we record the center of gravity to be 50. This is 50.2, like I said earlier. Sorry, this is 50.2. The center of gravity is 50.2. So we are putting that into record of the table, 50.2. That is the center of gravity. Okay, that has been recorded, 50.2 in the table. That is on top of the table. We have recorded 50.2 as the center of gravity. So now the next thing is to hang the mass of 20 gram. Hang the mass of 20 gram on one side of the meter rule and try to check the distance is going to balance between the knife edge. So this is the mass of 20 gram on the weight hanger. I'm putting it right here on the meter rule so that it can hang. Then I put the meter rule here and adjust the distance. Actually, I have to make this a distance of 10 centimeters away from the edge. So we're not given that in the script, in the procedures, but we can just adjust that to get what we want. Okay. Okay, after doing this, you can as well adjust the mass, since we are not told that we should adjust the mass to a fixed distance from the meter rule at the end of the meter rule. We are not told to do that, so you can actually adjust the mass. If you try to adjust the length and you see it's not readily getting balanced, so we can actually adjust the mass as well, so to see what happens. So let's go this way. It's not yet balancing. Okay, I love this method. After being like this, I try to adjust this way. I try to adjust the thread this way to see if it balances. Okay, now let's see. Now it's balanced. I think it's balanced now. So let us just rest so that we can conclude on our balancing. So there are some factors that can contribute to your balance, like this way angle was hung as if it was a pendulum, so therefore it can cause a little variation, but now you can see it is balanced. So we now try to check the distance between the mass and the knife edge. So on the knife edge I'm seeing 56.4 rather, and here I'm seeing 89.5. So subtracting the two, 56.5 minus 89.5, that will be our value. 89.5 minus 56.5. So I'm having. So as you can see, it still maintains the balance. Then 89.5 minus 56.5 is 33. So let's put that down. So we have 83.00. So that is our L when 20 mass gram was hanged. So now let us try to double the mass by adding this 20 gram with it. So by doing that, you see it loses the balance. So I add 20 gram mass to the weigh hanger, which means the mass has been doubled. Then I introduce that to the thread again. So then I place and try to balance again. And see the distance is going to actually balance. So let us try to maintain the initial position where the first one balances and see what happened to the second one at that point. So let this lay, let it be. Okay, we might not actually maintain that, but let us just try one thing or the other. So almost getting balanced. Okay, can you see? Let's see. It's balanced now. So it's balanced. So you can see the weighing mass and the air. So let's look at the setup all through. Let's go through the setup. So as you can see, it's totally balanced. So in this case, we record the distance as well. So here we have still on 56 points. Okay, this is on 71.5 and we have 56.2. No, 56 straight away. So we have 71.5 minus 56. 71.5 minus 56. So now let us try. We have recorded that 71.5 minus 56 gives 15.50, and that has been recorded in the table. So now let us multiply, or let's add 20 again to make 60. So that is the next line of action. So we put that on the meter rule as well, and then try to balance again. So let's see how it balances. So now see, it's balanced again. No. So that is okay. We can see the balance now. So this balance, let's go through it once again. So we can see how balanced it is. So since this is balanced, then the next thing we need to do is to keep the record again. So we have 56.5 just like the initial one. Then we have 67.7 with 56.5. So that gives 11.2. So 67.7 minus 56.5 gives 11.20. So that is recorded in 2 decimal place. So now let us go for the next mass, which is 80. Slotting that here, I have 80. So then let's hang it down there to see what next. So and try to balance again. Okay. Okay. So let's move on. So I think this balances. Let us study the movements. The factor that contributes to this bending is just because of the shaking of the suspended mass. So, and I think this is a very good balance. So it is actually balanced at this point. So we can put that the values down. So we have we have 57.3. Then here we have 66.8. 66.8 minus, then we have 57.3. 57.3. So after that, we have gotten 9.5 when we subtracted 66.8 from when we subtracted 57.3 from 66.8. So let's move to the last value by using the 100 gram on its own. So let's use the 100 gram and then contribute to that. Let's see what happens. Let's try to adjust. Okay, this balances straight away. It balances straight away. This balances straight away. Okay, still trying to, yeah. So we have achieved this as well. So at 100, we have at 100, when 100 m was mass was earned, we have 63.1 to 50. Then the knife edge point, we have 56.5. 56.5, 63.1, and we have 56.5. So that gives 7.60. 7.60. So for 100 gram, we have 7.60. Okay, let's look at the table now. We have performed the experiment and we have gotten our table. We have our L, the first L, which is 33.0. We have second L, which is 15.50. We have third, which is 11.20. And fourth, which is 9.50. And the last, which is what, 7.60. Now, let's look at our L inverse. We have 0.030, 0.065, 0.089, 0.105, and 0.132. So this is what we're going to plot in the table. Then we complete this step in the graph rather. We're going to plot this in the graph now, n on vertical axis and this on horizontal axis, and see how the graph goes. So let us move ahead in solving the graphs. Let's see how the graph goes, and at the end of it, get our slope and check another value. So let's go and check the graph on. Okay, let us look at the graph of our table. So to plot the graph, we choose a scale, and if you look at the title of the graph, let me show the title of the graph. It says graph of M against L inverse. Then the scale of the graph, we have on M axis. Don't make the mistake to say Y axis, because you are plotting M on vertical and L inverse on horizontal. So we have M axis 2 cm to 10 gram, then L inverse axis 2 cm to 0.05015 grams per centimeter rather. So let us put this into graphs, into graph drawing, and see what we are going to have as our graph. So on y-axis, I'm going to use, if this point on x-axis is 0.015, this will be 0.030, and this will be 0.045, 0.060. And I think with our table, let's look at the table. And I think with our table of which we have on the board, we have 0.30, 0.65, 0.8089 rather, 0.030, 0.065, 0.089, and 0.105 with 0.060. 0.132. So by plotting this on the graph, I can actually use 0.009. Yeah, I can actually use that so that we can get an approximate value of that on the graph. So then I can use 0.1 here and 0.13. So let's just plot the graph and see how it goes. So I'll rule my vertical axis at this point. This is my vertical axis. Using an HB pencil is very advisable, because by drawing a line is going to be very thick and it's going to show well than painting your graph. So can you see this? So that is my y-axis. So for my x-axis, I can actually take drawing this way, but for the y-axis, let's read for the 10 grams. So I have 10 here, 20, 30, 40, 50, 60, 70, 80, 90, then 100. So you have to plot your graph in such a way that you use 70%. It's very important. You must use 70% of your graph note, or 75 at least, to cover your 70%. So from here, I've read 1, which is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I can place it here to have 10.00. Don't forget, this is mass in gram. And this is 10.00. This is 20.00. This is 30.00. This is 40.00. This is 50.00. And we have 60.00. So see the way I arrange them. Then we have 70.00, 80.00, then 90.00. So we have 90.00 here. Then we have, this is 90.00. Then we have 100.00. So that is my y-axis. So for my x-axis, I can actually pick it from here. So this from here to here is 0 points. Let me draw the line. So from this point, I have my x-axis. Yeah. Yeah, that's it. So let's go for the first value, which is 0.015. 0.015. Here will be 0.030, and here we have 0.045, and we have 0.060. Then here we have 0.065. I think we have some of these values on the table. Yeah, 0.065. Then we have 0.089. Okay, let's keep taking this. So I have 0.080. So I think I have this. Yes, 0.080. Then we have 0.095. Then we have 0. Okay, there was a mistake here. We have 0.060. Then the next should be 0.075. Then 0.05075 plus 0.015. So that should give us 0.090. 0.090. So 0.090 plus 0.015. So that gives 0.105. So this gives 0.105.
Then if I add that with 0.015, that gives me 0.120. 0.120. So let me add that with 0.015. So that gives me 0.0135. 0.135 rather. 0.135. So that is that on the table. So let us now start fixing the values. Now you should know that since 2 centimeter is 0.015, so 0.015 divided by 10. So each tiny box you're having here is going to be 0.0015. So box, you can write that here, equals 0.0015. So we are good to go now. So let's start the plotting of the graph. So for 20 gram that we have here, we are going to have 0.30. So for 20 gram, this is 20 gram. I'm tracing that to 0.30, and that's it here. Yeah, you can see that. That's it here. Now for 40 gram, I have 0.065. So to get your 0.065, take this value 0.065. You have to divide it by this value, which is the box, 0. Divided by 0.0015. So this actually gives me 43.33. So which means we are counting 10, 20, 30, 40. Then you count 3. 1, 2. This is you. After this, you count 3. 1, 2, 3. So 43 approximately. Let's just place it on this line. 43, since it is 43.33. So let's just place it on this line, and that goes to 40. That goes to 40. This 10, 20, 30, 40. Then we have 1, 2, 3. So let's take that to 40. That's 30. Let's move on to 40. So this is where it lies. Yeah. You can see the first point and the second point. Now on the table, next we have 60 to 0.089. 60 to 0.089. So this is 60. Let's take 0.089. So 0.089 divided by the box 0.0015. So let's look at that. That is for 60 we have 0.089. So let's trace that by dividing 0.089 by 0.0015. We got 59.3. So let's count 59. This is 10, 20, 30, 40, 50. So 59 falls around this side, and then since 59 falls here, then we just trace it up 59.3. So we can actually look at that and then just approximate that. So this goes to 60. I think this is 50. So to 60, I'm gonna have this. Yes, directly to 60. So that is that. Then the next value I have 80 to 0.105. Actually we have 0.105 directly on the graph. So and that goes to 80. So 0.105 here to 80, and this is 80 here. So we trace them down to each other. This is 70, and finally we get to 80, so we put this here. Okay, as you can see, this is going to give a straight line. Actually, yes, straight line. And then so then the last value on the graph is 100 to 0.132, and actually we have 0.135. So let us say 0.135 132 rather, divided by 0.0015. So that is 88 exactly. So I'm going to count it here: 10, 20, 30, 40, 50, 60, 70, 80. So then 88. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that goes to 100. 88 to 100. That goes to 100. Yeah. So this is 90, and this is 100. This 1, 2. So we have it here. Yeah, the graph is now complete. So now we are meant to choose the fittest line, the best fitted line. So if I have to pick this, okay, pick this, okay, I think these three goes. One, then this, they go. So anyway, we have to choose in such a way that we are going to have those that are going to be left out of the graph is going to be on both sides. So let's choose wisely. So if I'm going to choose the first two, this goes this way. This is the first three. This is out of the way. Then let's take this. Let's take this. Okay. Yeah, I think it goes. Okay, we only have two that goes straight away with the graph. So at the end of the day, we are going to have one at this side, then two at this side. So they are evenly distributed. So we can actually take, let us see if we can take three values that goes well. So again, I think these, let us try to make a sketch. No. So if this goes with this, okay, so I think these three goes. Then from here we have another one. Yeah. So I think, but the two are on both sides. So we have three on the graph. 1, 2, 3. So you see that's 3 on the graph. Okay, let's go with these 3, or peradventure we go with these 2, and then the others are distributed evenly. So let's go with these 2, so that others will be distributed evenly on the graph. Actually, this line is not really straight, but okay, we can still go ahead with this. So this is a straight line on the graph. This is the straight line on the graph. So now that is our graph. So let's determine the slope of the graph S. We can see now that we have tried to choose wisely in such a way that we have one at this side and then two at this side. So let's say we are good to go, but we can actually take this 3, but that will be an error because the two party that is not on the line are not distributed evenly. So let us take our slope right from the known values. Ensure your slope line is a little bit bigger so you can take your readings in large values. So let's take the slope. So taking the slope from here down to here. So then I have my change in M, then I have my change in L inverse. So here, to determine the slope, I have the first value here to be 80 and second value to be 20. So my slope S is equals to change in M over change in L inverse. So that will be 80 minus 20 all over. So let's check the second value. We have 0 0.105 to 0 0.045. 0 0.105 minus 0 0.045. So let's determine the slope of the graph. So I have 80 minus 20, that gives me 60 all over 0 0.105 minus 0 0.045. So this gives me 0 0.06. So by dividing it with 60, so I'll say 60 divided by 0 0.06. So that gives me 1000. That's so huge. 1000. So then the unit of my slope is going to be what? You know, this is changing M over L inverse. So I'm going to have a gram centimeter instead of gram per centimeter. Okay, let's work out the unit because this is just a typical place. So we have gram all over unit centimeter, you know. Okay, that would be gram per centimeter squared. Gram per centimeter squared. So that's that for this. Or better still, gram, then I'm gonna have a centimeter raised to power minus 1 raised to power minus 1. So that is going to be what? Gram per centimeter squared. So that is the unit of the slope. So don't forget that we are meant to evaluate S equals 50 over S. Sorry, X equals 50 over S. And that will be what? 50 over 1000. So if this goes with this, so then I'm going to have 5 over 100. So 5 over 100 will give me so X is 0 0.05. So that is the value of my X. And still in that is the value of my X from the slope. So that is the end of the experiment. I think you can see how the graph goes and you best understand it. So we are going to look at the precautions taken. What are the precautions taken? You know, number one, you need to avoid parallax error in using your meter rule, because when you talk about an error, you must talk about the instrument related to that error. So I avoided parallax error in using my meter rule. I ensure the center of gravity of the meter rule is measured accurately. I ensure in each set of experiments, in each procedure I perform, I ensure that the meter rule balanced horizontally before taking my readings. So those are the precautions you are meant to take during the experiment. Thanks for watching. You can anticipate for more practical videos still on electricity and heat according to Waec 2022, and at the same time we are going to upload chemistry and biology. Thanks for watching. Please subscribe to our channel. It's free. Thank you.